Exercise 5.7 Continuity and Differentiability. So we have completed 4 functions. Now we will find the second order derivative for the fifth one. So function y is given to us x cube log x. We have to find d square y by dx square. So this is given to us and we have to find this. So first we will differentiate and find first order derivative, that is dy by dx. We differentiate again and then we will find d square y by dx square. So once you go through the introduction video to get the clarity, and also the first video to get the intuitive understanding on what exactly the first order derivative and second order derivative is. Okay, now let us find the second order derivative of the given function. So let us label the function. Let y is equal to x cube log x. Now we have to differentiate to get dy by dx. Differentiate both sides with respect to x. We have dy by dx is equal to, so in the place of y we will write x cube log x. Now this implies dy by dx is equal to, so how do we differentiate function into function? Product of function from the algebra of derivatives, which help us to get the derivative of sum of functions, difference of functions, product, quotient, right? So we will take the product of function. We will apply UV rule. So this is UV. So we will get x cube into d by dx of log x. So I'll write here u is x cube and v is log x. Okay. Then plus log x into d by dx of x cube. Now this implies dy by dx is equal to x cube into, so what is the derivative of log x? The derivative of log x is 1 by x plus log x into derivative of x cube. We will apply x power n rule, x cube. So here n is 3 into x to the power 3 minus 1. So therefore dy by dx is equal to x cube by x will be x square plus, we will write 3 here, then 3 minus 1 is 2, so we will get x square log x. So this is the dy by dx. Now the destination is d square y by dx square. So what we have to do to reach the destination? We have to differentiate. So we will differentiate again. So d by dx of dy by dx is equal to d by dx of x square plus 3x square log x, right? So this implies derivative of the first order derivative, we will get d square y by dx square. Now this is equal to, so derivative of function plus function, so which rule we have to apply? We will apply u plus v rule, right? Derivative of function plus function. So we will apply this. This is u and this is v. So we will get d by dx of x square plus d by dx of 3x square log x. Now this implies d square y by dx square is equal to derivative of x square, here derivative of x power n So we will apply 2 into x to the power 2 minus 1 plus derivative of 3 into x square log x. So when you have constant into function, like derivative of constant into function, how do we write it? Constant into function. So we will take out the constant outside and we will differentiate the inside function, right? Now this implies d square y by dx square is equal to 2 into x to the power 2 minus 1 is x to the power 1, which is x, plus 3 into, now derivative of x square into log x, we will apply uv rule. So this is u and this is v. So here u is x square and v log x. Now how we will differentiate? Let us write down that x square into d by dx of log x plus log x into d by dx of x square. Now this implies d square y by dx square is equals to 2x plus 3 into x square. Derivative of log x is 1 by x plus log x into derivative of x square. So already we have solved here derivative of x square, which is 2x, right? Now this implies d square y by dx square is equal to 2x plus, now let us multiply 3 into x square by x, you will get 3x, plus again if you will multiply here, you will get 3 times 2 is 6, x log x. So now this implies d square y by dx square is equal to, so we have like terms here, 2x plus 3x. So this will be 5x plus 6x log x. Now this implies d square y by dx square is equal to, so we can take x common here, right? So you will get 5 plus 6 log x. So therefore d square y by dx square, which is a second order derivative, is x times 5 plus 6 log x. So we completed the question number 5. Exercise 5.7, continuity and differentiability. We have completed 5 questions. Now we'll find the second order derivative of the sixth one, that is e power x sine 5x. So we have to find the second order derivative. So the function is given to us. We have to differentiate and find the first order derivative, then differentiate this again to get the second order derivative. So in introduction video, I have explained about the derivatives, and in the first video, I have explained about what is first order and second order derivative and how they are linked graphically. Now let us solve the sixth one. Let us label the function like y is equal to e to the power x sine 5x. So we want dy by dx, right? We want dy by dx. So how to move from y to dy by dx? We have to differentiate. Differentiate both sides with respect to x. We have dy by dx is equal to d by dx of e to the power x sine 5x. Now this implies dy by dx is equal to, so how to differentiate product of two functions? We will apply uv rule, right? uv. So here u is e to the power x and v is sine 5x. So e to the power x d by dx of sin 5x plus sin 5x d by dx of e to the power x. This implies dy by dx is equal to e to the power x. So derivative of sin 5x is cos 5x, and we should also differentiate 5x. d by dx of 5x plus sin 5x, derivative of e power x is e power x. Now this implies dy by dx is equal to e to the power x cos 5x, and derivative of 5x, when you have d by dx of ax constant into x power 1, constant into x power 1, we'll just write constant, so you will get 5 plus e power x sin 5x. So this implies dy by dx is equal to, so we'll write this first, 5 e power x cos 5x plus e power x sin 5x. Now this is the first order derivative. Now we want second order derivative. So how to move from first order to second order? We have to differentiate. So differentiate both sides with respect to x. We have d by dx of dy by dx is equal to d by dx of 5 into e power x cos 5x plus e power x sin 5x. Now this implies d by dx of dy by dx is second order derivative. So we will write d square y by dx square is equal to, so d by dx of u plus v. So when you have sum of two functions, we will apply sum rule, u plus v. So du by dx plus dv by dx. So what we will write here, d by dx of 5 into e power x cos 5x plus d by dx of e power x sin 5x. Now this implies d square y by dx square is equal to, so d by dx of constant into function. So when you have constant into function, how do you differentiate it from the algebra of derivatives? When you have derivative of constant into function, so we will take out constant, then we will differentiate the function. So e power x cos 5x plus d by dx of e power x sin 5x. Now this implies d square y by dx square is equal to 5 into, now d by dx of e power x cos 5x. So how do we differentiate this? We have to apply product rule, right? So we will apply product rule, uv rule. So this is u and v, if here also u, v. So we will get e power x d by dx of cos 5x plus cos 5x into d by dx of e power x plus, so again here e power x into d by dx of sin 5x plus sin 5x into d by dx of e power x. So this implies d square y by dx square is equal to 5 into e power x, derivative of cos 5x is minus sin 5x. Now I will write directly. Again, if you differentiate 5x, you will get 5, right? Plus cos 5x, and derivative of exponential function e power x is e power x, right? Then plus e power x into derivative of sin 5x is cos 5x, and if you differentiate 5x, you will get 5 plus sine 5x, and derivative of e power x is e power x. Now this implies d square y by dx square is equal to, now we will multiply 5. So you will get 5 times 5 is 25. 25 e to the power x sine 5x plus 5 e power x cos 5x plus 5 e power x cos 5x plus e power x sine 5x. Now can you observe any like terms here? So we can write therefore d square y by dx square is equal to, so here we have 5 e power x cos x, 5 e power x cos x. So we will add, we will get 10 e to the power x cos 5x. And here we have e power x sin 5x, e power x sin 5x. But here it is minus 25 and plus 1. So minus 25 plus 1 will be minus 24 e to the power x sin 5x. So this is the second order derivative of the function. So we completed the sixth one.